Welcome back. This is an Aleks training video on calculating the pH of a strong base solution. Strong bases are mostly hydroxides, either column 1, group 1 or group 2 hydroxides are mostly the strong bases. And remember, strong means that when you put it in water, it completely dissociates. It breaks completely apart into positive and negative ions. Now, this is an ionic bond. Barium is a positive, hydroxide's negative, so the water just tears it apart. So it's not like an acid where it's reacting with the water to make hydronium. So water is not included here. Water is just the breaker aparter. It's the solvent, so it dissolves the barium and the hydroxide ions. So I've got the formula at the top. And now it needs to be balanced. We'll make sure that it's balanced before we go any further. So I've got 1 barium, and you'll have 1 barium ion. You're going to have 2 hydroxides. That means I'm going to have a 2 up here. Okay, 2 up here. And so you're given 56 grams or micrograms of the barium hydroxide, and you want to know how much hydroxide that's going to give you, and then that the concentration of the hydroxide we can go further with. Okay, so let's start with what we're given. We're given 56 micrograms, so 56, not micrograms, milligrams. 56 milligrams. Let's go ahead and put it into grams. In 1 gram, there are 1,000 milligrams. Milligrams will cancel, and you'll end up with 0.056 grams. So we're interested in how many moles that is, so let's divide that by the molar mass. The molar mass of B and 2 O's and 2 BA and 2 O's and 2 H's is 171.34168 grams per mole. Grams will cancel, and you end up with 0.0003268332 moles, okay, of barium hydroxide. All right, so our next question is, how many hydroxides are there in so many moles of barium hydroxide? Okay, so let me write it again. Barium hydroxide, barium is in group 2, so it's positive 2. Hydroxide is negative 1. That means there has to be 2 hydroxides joined to this barium. So if I have this many moles of barium hydroxide, so let's say I have 1 mole of barium hydroxide. How many hydroxides do I have? How many moles of hydroxides? I'm going to have 2 for every 1. Okay, so I'm going to have double that. Whatever this number is, I'm going to have to double, and that'll be the concentration, or that's the number of moles of the hydrogen or the hydroxide. So take that number, multiply it by 2, and you're going to get 0.0006536665 moles of hydroxide ion. So there's your moles. What's molarity? Molarity, remember, is equal to moles over liters of solution. So I have this many moles. How many liters do I have? Well, it says that I need it to make 50 milliliters. So 50 milliliters, okay, it divide by 3 places, and you're going to end up with 0.0006536665 moles over 0.050 liters. And you'll end up with 0.01307329 0.073 molar. So there's your concentration. So we're going to have the concentration of OH as 0.013073293 molar. Okay, we're halfway there. We now have the concentration of hydroxide ion. Now I need the pH. Okay, so a couple more steps. I need to remember that the K sub W, or the ion product constant, is 1.01 times 10 to the negative 14. And that number also is the product of the two concentrations of hydroxide and hydronium. Well, we have the concentration of hydroxide, the molarity of hydroxide. So when we put it over here, this is 0.013073293 molar. Then I have this number equals something times this number. So when I want to get it by itself, I'm just going to divide that. So it's going to be this number divided by this. Right, so the concentration of hydronium equals 7.725673964 times 10 to the minus 13 molar. Well, last step. What is the pH? The pH is the negative logarithm of the concentration of hydronium. So put the number in, push the LOG button, push negative. Okay, I end up with my calculator answer of 12.112063362. And then I have to remember that if I have the number of significant digits that I have at the top, which is 2 here and 2 here, when you're translating them into pH, refer not to the total number of significant digits, but the digits after the decimal point. So if there's 2 here, I have to have these 2 digits here. So my final answer is that the pH is equal to 12.11. Lots to chew.